Hi there, welcome back to my YouTube channel. I've been getting quite a few questions in my inbox lately about AWS Lambda and the AWS SDK for Node.js. So I thought, why not make a video and even maybe a series all about cloud services and infrastructure? Sounds good? Awesome. Yeah, so let's dive right into it. What exactly is AWS Lambda? What can you do with it? And where does it fit into your architecture? In simple terms, AWS Lambda is a serverless compute service. Now, you might be thinking, what the heck does that mean? Well, imagine running your code without worrying about any service, no setup, no maintenance, just code. AWS Lambda lets you do that. You can run your code in response to events, and the best part, you don't need to manage any underlying infrastructure. Oh, and it gives you up to about 15 minutes of execution time per function. Yeah, that's right. No more messing with service. Now that you're here with me, let us take a quick trip down memory lane. Back in the day, I'm not that old. Deploying applications was a serious chore. You had to get your own hardware, yep, the actual physical computer, then set up a layer of virtualization. Then you pick the operating system. Then you also choose your runtime environment, and then finally you run your code. So basically, you had to go through all of these steps, okay, just to deploy your backend. It was a massive headache, super expensive, and then a nightmare to manage. You needed a whole team of engineers to keep all of it running. But then things started to get better, and then things also started to get easier. We got infrastructure as a service, then we got platform as a service, then we also landed with function as a service. This is where AWS Lambda shines. It falls into the function as a service category, where you break down your application into individual functions, those tiny powerful components that make everything tick. And guess what? This is what serverless architecture at its core it's all about. So if you're ready to take your cloud game to the next level, stick around. We are just getting started on this journey through AWS Lambda and the world of serverless architecture. What is serverless in AWS? AWS describes serverless as a service that have the following characteristics: no server management, automatic scaling, which is auto scaling, high availability, that is fault tolerant is built in, and then it also exists in multiple availability zones. And the billing model is pay as you go. This means that you only pay for what you use, therefore you don't pay for idle time. I want to introduce you to AWS Lambda through the AWS console. So when you log into the console, you can look for Lambda here, or like me, if you already have it showing, you can just click on it. So I can just click on Lambda. Then I don't have any Lambda functions created. So what you can do is you can create a new one. So create a function, and there are a couple of configurations you can do. So we can author one from scratch. You can use a blueprint. You can do container image. Um, yeah, it can get complicated really quickly. But yeah, we just start with the basics. So function name, we can call it anything. So let's call it hard tech test. And then we have to choose the runtime. I prefer Node, but you can choose Python, you can choose Ruby, Java, and then and other runtime environments. The architecture, you can also go with x86 or ARM. So I'll just settle with let's say ARM. Yep, that will do for me. Then yeah, you see this part where we have some other additional configurations you can take. If you want your Lambda function to have a URL, okay, so like a link, a URL that you can access over the internet, right? You can just click this to enable that. Yeah, but if you don't need it, you can just untick it. There is also the execution rule. You can create a new one or you can use an existing one. It's up to you. But for now, I just want to create a new one with my Lambda function and then give it basic permissions. So yeah, basically the default stuff. So I can just go ahead and then go to create function. It is going to take some few seconds. Okay, now we have our function created successfully. So this is the interface that we have here. So the top part talks about some function overview. So you can see your function with the name. There's something called layers. We'll talk about that one later. There's another thing you see over here, trigger, and then we have destination. I'll also talk about those ones in a bit. Now, when you come down, you see this source code side, right? Now, this part, it gives you some kind of an IDE, let's say screen, right, where you can write some code and then test your Lambda function. Um, in a in a production environment, or let's say in a real world application, this is not where you're going to write your Lambda function code, right? There are a series of steps, pipelines involved to deploy your code. Okay, but this is a user-friendly way to do your testing. So if you look at the left side, we have where you can see the directory, right? So we have a folder called lambda hardtech test, and then we have in here a file called index.mjs. So basically, this is the file that contains Lambda handler. Okay, so you have to take note of this function, the handler function. So basically, the handler function is where all your runnable code goes. Okay, so any code that you want to run, it has to be inside the handler function. All right. Um, Now, if we look at the Lambda function, we can see a parameter here which says an event. But before we do that, let us click on test. So if you click on test, right, the first thing it asks you to do is to create a new event. So what is an event? An event is anything that invokes your Lambda function. When I talk about invoking, basically anything that calls your function, anything that lets your function to start. And then usually events are in a form of JSON. When you scroll down, you can see event JSON here, and you can see key and then value. So this is just an example that AWS is giving you. Now, when you go to the template, there are some templates you can choose to use. So for example, you can go to, let's say, API Gateway HTTP API. It gives you some kind of event that looks like an API gateway integration with Lambda. So this is how it will look like. We are not interested in this, but yeah, you can experiment with that one later if you want to, just play around. So for now, we'll just settle with the hello world one. We click that, and then it gives us some default values. You can change it. You can even clean everything if you want, but we just for testing purposes, I'll just keep it the way it is, and then I continue. And then you can give it a name. Let's say test event. Then you can format it if you want. Then we can save. So I have saved the event. Now I can go ahead and then test. If I click on the test button, now we can see that we have a response. The status code is 200. The body says hello world. Now where are we getting this one from? If you look at the index.mjs, you can see that we have a response object defined here where we have status code 200 and then the body JSON.stringify, and then we say hello from Lambda. Yeah, so if you go to the execution results, these slashes that you see is because we are doing JSON stringify. Now, if you're using a programming language like Python, you can do a JSON dump and then you get a similar output. Now, let us make it a little bit different. So I can go up here and then configure test event. And so it says an event name is required. Okay, so you can, I don't want to create any event. All I want to do is just edit the saved event. So I can just highlight this part, take that out, and then I'll say name. Then I pass my name. So this has to be a string, and then format JSON, then I'll save. So this has overwritten my previous event with the new one. That event will have my name in there. Now, instead of saying hello from Lambda, I can do hello. My name is, and then I pass my name. So I can say event dot and then name. Okay. Now, if you make changes to the code in here, the changes does not reflect automatically. So you can see it says that changes not deployed. So what you have to do is you have to click on the deploy button to deploy the new changes. So if you click on this, it is going to deploy the new code to the Lambda. It has deployed successfully. Now we can do a test. Okay, now this is the response. In the new response, you can see the status code is 200. Inside the body, you can see, hello, my name is Julius. Nice. Now, because we are running this in Node.js, JavaScript runtime environment, what we can do is any code that we can run in JavaScript, we can basically do the same thing inside Lambda. I can say const date, and then I'll say new date. Then I'll do to ISO string. I think they should do. Then I can do a console.log. So the log, then I'll pass date in here. I've made a change, so I'll just go ahead and then deploy the new change. And then click on test. Great. Now we can see the response. However, for the console.log date that I did, if you want to see that, you have to go through the function logs. Okay, so if you do console.log, it goes to the function logs. Okay, and then the default console.log is an information log. You can see that I have info here, and then it says the date, like the current date time. Great. Now there's another thing I want to show you in Lambda. So for the parameters, there's another parameter called the context. The context. Now let me define these parameters. I think I'm not. So the first parameter, the event, this is the data or the payload that triggers the function. As simple as that. That is what the event is. Now for the context, this object contains metadata about the invocation, function, and then execution. So what we can do here is we can log both of them and then see what we get. So I'll just clean up this quickly, and then I'll say console.log, then event. So I'll just pass event here. Console.log. Then for this, I'll say context. So I can pass context. And after I'm done, I just have to deploy the changes. So it is done deploying. Now we can click on test again. So it is done running the function. Now when we go to the info side, right, because we are doing console.log, so we assume it is a login, it is an info log, right? So if you go to info, you can see event here, and then you can see the event value, right? And now if you go to context, this is what you see. We can try to break down what is happening here. Now look at what the context is giving us. It is giving us a callback. It is giving us succeed, fail, and done. If you notice, if you look at this carefully, you get to realize that these are functions, right? So fail, done, and then succeed. Then it also has something like the function version. It has the function name, and then it has the memory limit and so on. So basically it contains some details and some information about the function. Okay, I can just come in here, and then what I'll do is I'll just say function name, But before that, I just want to do const and then say function name. Then I'll give it context dot function name. Let me make sure that is what we have here, function name. And the other thing I want to do is I want to get I want a function. Okay, so get remaining time millis in millis. This one, it gives you the time left for your function to time out. Okay, so that is what that value is. So I can do const and then say time remaining. Then context dot, because it is a function, you have to bring your brackets. Then what again? I just want one more thing. Okay, yeah, memory limit in MB. We can also say const memory limit context dot memory limit. That one was not a function. Function name, we just pass function name. For time remaining, we pass time remaining. Oh, okay, time remaining. We pass time remaining. For the memory limit, we pass memory limit. Yeah, I think this looks good. Then we can do deploy. It is done deploying. Let us test. Okay, it is done running. Now we can see the response is 200. The function name is that. The time remaining is that. The memory limit is 128. Now let us look around for anything we may find interesting. So we can go to test. Yeah, so this is where we create our test events, right? And then we can also edit the existing ones. We already talked about these ones. We go to monitor. It is loading. Okay, so this is where we get some information about our function app. Because we've run the function app a couple of times, we can see that the chart is being created. So it gives us some information about the duration, error count and success rate, and so on. Let's see what is in configuration. Okay, so state machines. Okay, let's start from the top. So general configuration, we can see memory, timeout, and then ephemeral storage. So if we had a description, it would have showed over here. So these are things that you can edit, right? So you can increase the memory, you can increase the timeout. If you go back, you get to realize that when we're logging the time remaining, the value was less than 3,000 seconds, right? So that one was clear that the default timeout was 3 seconds. If we go to triggers, we'll talk about this one in a bit. Permissions, if you want to configure any permission, you do that here. Destinations, we'll talk about that one in a bit. Function URL, I've already talked about what function URLs are. So you can also create some for your function. And then environment variable. So almost every backend needs some kind of, almost every application needs some kind of environment variable. So you can set them up here. Tags, if you want to add tags to your Lambda function, you do that here. If your Lambda function, you want to add it to a VPC or connect it to a VPC, you can also do that configuration over here. So these are lots of options you can choose from and then edit. Now, state machines, these ones are like very interesting. Okay, so I got exposed to state machines and then I've loved this since. So what is it? So in AWS, state machines are typically used with services like step functions, right? So it helps you to coordinate workflows and then allows you to execute and manage multiple AWS Lambda functions in a defined order. Yeah, so it's really powerful if you know how to use it. Let's go to alias. So basically, these are like another name given to the versions of your functions. Okay, and then you can go to versions, like the different versions of your function. So what is the summary here? If we go back to what we have done, we can talk about the anatomy of a Lambda function. We can talk about the handler function. Basically, it is the entry point of a Lambda function. So it is where the main logic resides. So we can think of it as the main function in a traditional program. And then we also have the event. This is where the Lambda function is invoked. The function receives an event object. The object contains all the data relevant to the event that triggered the function. For example, an API gateway can trigger the function. The event object would include details like the HTTP method, the headers, and then the request body. Then we have the context. This is your gateway to information about the execution environment. The context object provides methods and properties that give us details about things like the function execution time remaining, the request ID, and other things. Understanding these components is key to effectively working with AWS Lambda. They are building blocks that let you write powerful and then scalable functions. Now, we are here on my drawing board. I have a couple of topics in here I want us to discuss. I'll start with what does Lambda free you from, or what does Lambda do on your behalf? So let's talk about all the heavy lifting AWS Lambda takes off your plate. The first item I have here is load balancing. Imagine trying to manually distribute incoming traffic across multiple servers to ensure none of them gets overwhelmed. Lambda handles all of that for you, automatically balancing the load without you having to do anything. The next thing is auto scaling. In a traditional setup, you would have to constantly monitor your server usage and spin up or shut down instances as needed. With Lambda, it's automatic. Whether you get 10 requests or 10,000 requests, Lambda scales seamlessly to handle all of that. Handling of failures. Failures are inevitable, but managing them is a headache. Lambda comes with built-in error handling and retries. So if something goes wrong, it will automatically try to fix the issue without you even knowing. Security isolation. Lambda runs your code in a secured environment with strict isolation from other functions. This means you don't have to worry about other people's code interfering with yours. Security is baked in from ground up. OS management. Forget about patching, updating, or even choosing an operating system like I showed you before. Lambda abstracts all of that so you can solely focus on your code while AWS takes care of the rest. Managing utilizations. So no more stressing over how much CPU or memory your function is using. Lambda optimizes the resource usage for you, ensuring that you only pay for what you use and so much more. Now let us go up. I have this diagram here. So basically, I want to talk about components of serverless systems, okay, in relation to Lambda. Let's break down what makes up a serverless app. So we have the event source. This is the trigger, the thing that kicks off your Lambda function. It could be something like a change in your database, a user request to an endpoint, or even a file being uploaded to S3. Basically, any change in states can be an event source. Then we have the function itself. This is where the magic happens. So it is your code. Lambda supports multiple runtimes like Node.js, Python, Ruby, and so much more. It also has the runtime API that helps you to onboard your own runtime environment. So if you want to run, let's say Rust on Lambda, you can use that to bring Rust to Lambda. So when an event triggers your function, this is where your code gets executed. Then we have the services. After your function runs, it often interacts with other AWS services, whether it is writing data to the database, sending a message to a queue, or responding to a web request. This is where the function outputs ends up. In a nutshell, serverless apps connect an event source to a function, which then interacts with other services to get things done. It's a powerful and efficient way to build modern applications. I'm going to move to the next tab, and then we are going to talk about the AWS Lambda execution model. So what is it? So basically, these are the type of ways that you can invoke or call your function. They are more like approaches or patterns to invoke your functions. So AWS Lambda functions can be executed in three main ways. I'm going to break them down. So the first one is the synchronous invocation. This is the most straightforward. When a service calls your Lambda function, it waits for the function to process the event and then returns a response before continuing. So you can think of it like making a phone call. You wait on the line until the other person answers. And when you finish the conversation, you end the call. I have this example code here. Basically, it is a Python code to try to explain what the synchronous invocation looks like. So we are importing JSON here. We have a Lambda function handler. We've already seen how it looks like in JavaScript or Node.js, right? With Python, we define our Lambda handler, and then we have the event and then the context. We already know what these are. And I have this comment here. Basically, this comment says that simulate some process. We are simulating a process that is occurring as a result of the Lambda function being called or being activated. So as this processing is happening, we are going to wait for the process to finish before we return a response to the user or the client. If it takes, let's say, 10 seconds, we are going to wait for 10 seconds. And when that is done, we create our response. So we have our response dictionary here, and then we do a JSON dump, and then we return the response. We say that 200 successful. So that is how the synchronous invocation is done. So what are the use cases? So basically, API gateway integration. Let's say you want to build APIs, right? And then you've connected the gateway to your Lambda function. Because you've built your API such that, let's say, it doesn't require too much time to do the processing. So let's say you're just putting something in database. This is almost a real-time application. This is where you're going to use something like a synchronous invocation. So the request comes to the gateway takes it to the Lambda processes it and then returns something to the gateway, then which is later returned to the client. Simple as that. And then real-time processing, just like I've already explained, any kind of real-time processing can also follow this model of invocation. The other model of invocation is the asynchronous invocation. With this one, the calling service doesn't wait for the response. So it triggers the function and then moves on, letting the Lambda function handle the rest. This is like sending a text message where you fire it off and then go about your day, trusting that the recipient will get back to you when they can. In this example, Python example, you can see that you can see inside our handler function, I have this comment here which says that process the event asynchronously, don't wait. So basically when the event comes in, we do the processing. However, we immediately return a response to the user. And then we can say that the status code is, let's say, 202. So the accepted status code. Now, when we send this 202 to the client, what we are trying to say to the client is, when your request came in, we have acknowledged it, we have received it. However, we are processing it in the background. So basically, we just send some kind of acknowledgement to the user to say that we have accepted your request. Okay, but that does not mean that we are done processing the request. You get a difference? Yeah. So this one, we don't wait. When the event comes in, we immediately start processing, and then we immediately get back to the user that we have actually accepted your request, but we don't wait for the processing to finish before we send a response to the client. The other thing, okay, so the use cases. So we have event-driven architecture. If you have, let's say, a solution and then you want it to be based around event-driven architecture, this is a very good approach where you're going to use this asynchronous invocation. If you want to also process large batches of data. At the start of the video, I showed you a Lambda function where the timeout was 3 seconds. So if we want our timeout to still be 3 seconds and whatever processing we are doing takes more than 3 seconds, we can use this asynchronous approach where when a request comes in, let's say the request will take about, on average, let's say 15 seconds to process. We are immediately going to get back to the user. We have accepted your request. But because the processing is not done, we are not going to send details about the processing to the user. We are just going to tell the user we have accepted a request, right? And then the processing will continue in the background, which is on the Lambda function. So it can take as long as it needs to take. If it is 15 seconds, 1 minute, yeah, it should do that. What are the use cases here? Event-driven architecture, I've already talked about that, sorry. Processing large batches of data. So if we have a data or data set that is huge, and then we want to process them, because it is going to take lots of time to do this processing, we can do it asynchronously. So we just acknowledge to the user that your request is in, we are processing it. The Lambda function deals with the rest whilst we continue the processing. And then we have the poll-based invocation. So what is this? This is often used with event sources like SQS, which is simple queue services, or DynamoDB streams, where Lambda keeps polling the event source for new data. When it detects something new, it triggers the function to process it. Imagine it like a diligent worker constantly checking their inbox for new emails and then processing them as they come in. In this Python code, we can see that we have an event dictionary, and then for each record, right, we are processing the item in the record. If we have 200 items in the record, we are going to pull the event, let's say 200 times, and then process the record one by one. And if this is a queue, we are going to pull the queue. So if any new item comes into the queue, we are going to check if there's a new item in the queue, and then we do processing. If there is no new item in the queue, then we are done. If any new item comes into the pool, into the queue, we we get into the queue, we retrieve the item, and then we process it. So that is how the pull-based invocation is done. When is this used? So if you want to process messages from a queue, like I've used in the example, if you want to do real-time streaming, like data processes in a real-time fashion, this is also a very good approach. Now, I'm going to take us back to the drawing board and then have a chat about the use cases for AWS Lambda. Here we are. And then, so what I'm going to do is I'll pick each use case and then talk about some key use cases under that particular use case. So for example, in web applications, how is it used? I'll briefly talk about that. So some of these sub use cases or use cases in here, I have not personally used Lambda in that context, but I've read and then heard about people using it in these contexts. So I know it is actually possible. Yeah, so let's just talk about these. So Lambda is versatile and can be used in a variety of scenarios, ranging from web application to IT automation. So here are some of the applications where Lambda shines. In web application, you can use it to serve static content like HTML, CSS, and then JavaScript. You can also use it for complex web apps, power dynamic content, and then backend logic for your web application. Then you can also use it for packages, right? Where let's say you have frameworks like Express and then Flask, so you can easily deploy these packages using these frameworks for web application. Then we also have the backend use, right? In this use case, you can use it to build your scalable backend, maybe for your web or mobile application. You can also like integrate with other AWS services to handle backend logic for mobile applications and the IoT part. If you have any IoT service, you can use Lambda as the backbone of that. So you can use it to process these IoT devices in real time and then trigger actions based on the data that you receive. Now, to talk about data processing, I talked about the real-time processing scenario, right? So you can use it to handle streams of data, or you can use it to do real-time data processing task. There is also this batch processing that you can do. This one I've used it personally to do batch processing before. You process large volumes of data in batch jobs, and then you can also use it for transformations like ETL task. So that is extract, transform, and then load. You can use it for these processes. Then we also have chatbots. I've not used it for chatbots before, but yes, people actually do use it for chatbots. You can use it to power the chatbot logic and then implement the backend for that. And then you can also integrate it with AI and then machine learning services. We have Amazon Alexa. You can also use it for the Alexa skills kit. So this is where you create custom skills for Alexa, and then you leverage the power of Lambda to process and then respond to voice commands. Then we have the IT automation. This one I'm curious, maybe I may try it sometime in the near future. So basically, you can use it to handle infrastructure management. So you can use it to automate the management and then scaling of some of your cloud infrastructure, right? And then you can also use it, you can also integrate it and extend AWS services to meet specific needs when it comes to the IT automation aspect. To conclude, as we have seen, AWS Lambda is a versatile service with wide range of applications. Whether you are building web applications, data processing, automation IT tasks, Lambda provides a scalable and cost-effective solution. Actually, I'm actually done with the video, but after this part, I'm going to do a very short tutorial, basically examples of how to use the AWS SDK on Lambda, because this one was requested by some subscribers of the channel. So I just wanted to do some video about how to use the V3, that is the version 3 of the AWS SDK. So if you feel like you want to learn something new, just stick around. Thank you. We are back to the AWS console. Now, if you have been following, you already know how Lambda function works. So let's skip straight to the integration with S3 using AWS SDK version 3. One thing to note is that the AWS SDK version 3 has a modular architecture, meaning we only load the components we need. which keeps our Lambda function small and efficient. And there's an important update that makes it even easier now. So before we jump to the code, let me address the previous major update. So starting from Node.js runtime version 14x and later, AWS Lambda now comes with the AWS SDK version 3 pre-installed. So this change was rolled out around late 2021, and it's a game changer for simplifying your Lambda deployments. Why is this important? In the past, we had to manually install the AWS SDK version 3 as a dependency. That adds extra steps to your deployment workflow and increases the size of your Lambda deployment package. But now AWS has bundled the SDK version 3 into the runtime itself, so you don't need to install it anymore. So there are several benefits. So the first one being that you have smaller deployment packages, right? And then the second thing is the automatic update. So you get like the latest versions. Now that we know what we need, let us go ahead and then write the code. This time I don't want to write a code in here. What I want to do is I want to write the code in VS Code, basically on my local ID, right? So that I can have access to IntelliSense and then code completions. Now to provide some context, I have created a new folder. I've called it hard tech test, like the same name for the function, and I've created a new file. I've called it index.mjs, and then inside the new file, I've copied and pasted the same code that we have on our Lambda function in here. What I want to do next is to install the AWS SDK version 3. I explained to you before that you have to install the components that you need. So we are going to see how you can do that. So you can just go to terminal, add a new terminal, and then I'm going to install what I need. So in this case, but okay, now before I do the installation, I have to initialize npm, right? Because it is not initialized here. There's a new folder. So what I can do is npm init, and then I can say dash dash yes, just for a quick initialization. Then I can do npm install. Then I'll say at AWS SDK, then slash. In this case, I'm interested in the S3 component, right? So what you can do is you can do client, then you say S3. If you want the components for DynamoDB, you can still do the same thing. So you can do at AWS SDK slash, then you say client, then DynamoDB. Doing this is going to install the two components that we need, or the two packages. So you can see that two packages have been added. If we go into our package.json, we can see that we have the client DynamoDB and then client S3. Perfect. Now let us go ahead and then write some code. Inside our index.mjs, we don't need all of these. We don't need these, so I'm just going to get rid of this. And then I'm going to import the necessary stuff. So at the top we can do import, then from we can say AWS SDK slash client S3. Then what do we want to import? We want to import the S3 client class. So I've imported that. And then we also want to import the list buckets command. So list bucket command. Yeah, that one. Now that we have access to the command, we have to create an S3 client object. So we can say S3 client, then we do a new S3 client. Okay. Now this one has a couple of parameters you can set. So for example, if you want to set, let's say, the region, you can just do region, and then if you have the region inside your environment variable, you can just do process.env. Why is it saying processing? Process dot, come on, process dot env. Then you can pass, let's say, AWS, then region. Now that we are done creating our object, what we want to do is to create our function, right? So the list bucket function. Okay, let's call it list bucket. Yeah, just list bucket is fine. List bucket. And then that is going to be an asynchronous function, so we can do async. And then we'd have that. Now we do a try catch. Now if there's an error, we want to throw the error. So we can say new error. Then we can pass failed to fetch buckets. Then we can add error message, right? So error dot message. So we've handled a case where we have an error. Then what we can also do next is now to make the request. So in order to do that, we have to create our command. So we say const and then command. So we have new, then we say list buckets command. After we have listed the buckets, we now, sorry, after we have created this, we now have access to the command here. So this one also has a couple of options that you can set, right? So you can have a look at, for example, this quick documentation. So you can define something like an input, right? Then you specify the max buckets in terms of quantity and then so on. You can also set something called a continuation token. So you can read more about that in the documentation. Then you set it as needed. So after we have created our command object, what we can also do is to create a response. Then we have to make use of the S3 client object to send the command. So we do send, then we pass the command in here. So after this is done, what we want to do next is to return. We want to return our response, right? So we can do response. But in this case, if you do response dot, you get to realize that you have some information here, right? So like owner, continuation token, and so on. But we are interested in the bucket, so we can do dot buckets dot, and then we can map this, right? Then we say for every bucket, okay, just give us the bucket name. So we can do bucket dot. So we have the creation date and then we have the name. So we can just say the name. Now this is looking really good. Then we come into our handler function now. So we also do the try catch here. If there's an error, what we want to do is we want to return 500 to the user. So we can do return. Then we say status code. Then we pass 500. Not only that, we also want to be able to add the error. So we can say body, then JSON.stringify. Then we say message error the message. Then we come to the try block. Inside our try block, what we want to do is we want to get all the bucket names. So we can do const. Then we say bucket names. Then we do await. Then list. Okay, so instead of list buckets, we want to do list buckets, right? So I'll just change the name of this function. So list buckets. Yep, we have that. We call this function, and then we do a return. So we want to send 200 to the user. So we say status code. We send 200. Then inside our body, right? We do JSON.stringify. Then in here we say buckets, or yeah, bucket names. We do bucket names. Then we pass bucket names. So because we are doing bucket names and bucket names, we can just do bucket names, right? Yeah, so this is looking good. Now let us test this. So in order to test this, we just have to copy this whole function and then go and paste it inside our Lambda function. So I'll just copy the whole of this, the whole of the code, and I'm going to paste it into the Lambda function. Here in the console, we can replace everything we have in here with the code we copied from the IDE. So I have the code in here now. Now, because I explained before that the AWS SDK version 3 already comes with Lambda, the Lambda runtime, we don't necessarily have to add any npm packages. So yeah, we don't have to do all of those things because like we already have it. So if we are doing any imports, that means we already have access to this package, right? So this is okay. Now we just have to make sure that the code we've pasted is correct. So line by line, everything seems okay. So return. Now this does not look correct. All right, so S3 client.send is an asynchronous function, so we can do await here and then get rid of this await. We can also get rid of this. Yeah, so response the bucket. Then we are returning if there's an error, we do that. And then list buckets, just like the one at the top. Await. Yeah, I think it looks good now. So we can just go ahead and save and then deploy the changes. So it is updating our Lambda function. Okay, so it has updated successfully. Now we can test. We got an error. It says the status code is 500, and then it says that failed to fetch buckets. The user is not authorized to perform list all my buckets. So this is the operation we have to grant some, like we have to give access to our current row so that it will be able to access these buckets, right? In order to do that, we can just go to configuration and then let's see permissions. Okay, yeah, then we go to our row. So you can see this row, right? The row we created when we were creating the Lambda function. We can click on this. Okay, so we have this row. Now we can add some permissions here. So we can go to add permission and then attach policy. Then we can look for Lambda, S3. So for now, let us give it S3 full access, okay? So we don't need any specific one. We just want full access to S3. So we can go to add permissions. So we have successfully added a permission. Now we can go back to our Lambda function and then retry the code. So let us test again. Okay, so you can see that we have gotten a response of 200 now. And then we have the bucket names, AWS SDK Node.js tutorial. So these are the buckets that I have currently. Now I'll just duplicate this tab and then create a new bucket so that you get to see that the code is actually working. And then I'm just going to go to the home and then S3. So this is the bucket that is showing. After we run the Lambda, I'm just going to add a new bucket. So let's just do that and then create bucket. Okay, so we've created another bucket. So we have two buckets now. I'll go back to the Lambda function and then run this test. Okay, now we are seeing two buckets, right? So AWS SDK Node tutorial and then new bucket hard tech. Just to make this one look better, I'll just get rid of the JSON stringify. For the body, I'll just pass bucket name. So I'll just deploy this code and then test again. Great. Now we see an array of two strings, right? So these two strings are the names of our bucket. That is how you use the SDK version 3, the AWS SDK version 3. So basically, you just have to know how modular it is, and then you also have to implement the command pattern. Before we finish up, let us go over some important best practices that will serve you well. So the first thing is to leverage the pre-installed SDK. So always use the pre-installed SDK with Node.js runtimes 14x and above. It also make your Lambda function smaller and more efficient. The command pattern. So the command pattern provides a clear modular way to interact with AWS services, making your code easier to maintain and expand. And then you also get access to minimal like package sizes. So by not including the SDK in your deployment package, your Lambda function will experience faster code starts and then low memory usage, improving the overall performance and then reducing cost relatively. And then error handling. Always remember to make sure you handle errors gracefully in your Lambda functions. In this case, we catch and log any errors that occurs during packet listing processes. The other thing I wanted to also add to the video, but it is only going to make it longer, is how to use third-party packages. So, for example, if you want to install something like Axios and then push all of this to the Lambda function, how to go about that. But it is quite a straightforward process. So you install your packages, you zip it up, and then you push it. You saw in the examples over there, you can either upload the file in a zip format, or you can also put it in an S3 bucket and then upload it from there. Usually in real world applications, let's say production ready applications, what we do is there's a pipeline that we create, right, that will handle the zipping process, and then it will also handle the pushing process. So basically, if you want to push to, let's say the function directly, or if you want to maybe push it to an S3 storage and then get it from there, yeah, like the pipeline handles all of that. So that is how you go about it. Basically, there's an automation step in between. Okay, so after you write your code, you don't manually drop it into the function, but you can have a pipeline where when you run the pipeline, it does all of this process for you, and then it pushes the code and then deploys it. But the whole purpose of this video is to introduce you to Lambda function and then how it is being used. Thank you very much for sticking around. I really appreciate it. Have a good day.